express 2x square minus 12x plus 11 in this form, the completed square form, where a, b, and c are constants. Okay, so this is a question on quadratics actually. Okay, let's first take 2 common from the first two. We get x squared minus 6x, and just let 11 be for now. Now I'm going to use the identity a square minus 2ab plus b square here. Okay, I'm going to try to write this in the form of that identity. So 2 times a square minus 2, a is x, b is going to be 3, so that this becomes 6x. Now we have to add b squared, so that's going to be plus 3 squared, and we'll also have to subtract 3 squared to make that even, and plus 11. All right, so now these three combined make, let me use bigger brackets here. These three combined make x minus 3 whole squared, and then there's a minus 3 left, or a minus 9, sorry, left, and then there's a plus 11 outside. So this becomes 2x minus 3 whole squared minus 18 plus 11. That gives minus 7 outside. So this becomes 2 times x minus 3 whole squared minus 7. Okay. And the domain of fx, next part it says the function f is defined by, excuse me, 2x square minus 12x plus 11. That means fx is the same function we just wrote in completed square form. So I am writing fx as 2x minus 3 whole square minus 7, and the domain is x is less than or equals to k. State the largest value of constant k for which f is a one-to-one function. Let's sketch it first. The turning point is going to be 3 comma minus 7. So 3 here, minus 7 here. We make a U-shaped graph which passes through 11. So something like this. This is not a one-to-one function because the horizontal line test fails, as the horizontal line cuts this graph at 2 points. But what they're saying is that, just a second. Let's say this is the turning point. Okay. So state the largest value of constant k for which f is a one-to-one function. Now, the domain is x is less than or equals to k. So what should k be so that this becomes a one-to-one function? Since it says k, x is less than or equals to k, so then we'll choose this side. So if we only consider the black part of the curve, now this is a one-to-one function. And the maximum value or the largest value that k can take so that this is a one-to-one function is going to be k equals 3. Okay, moving on to the next part, which is for this value of k, express f inverse of x and state the domain of f inverse. Okay, let me write fx again over here with its domain. So fx is 2x minus 3 whole square minus 7, and its domain is less than or equals to 3. So now we find the range, the f inverse of x. So y equals 2x minus 3 whole square minus 7. 7 adds, 2 divides, then we square root, write plus minus. Negative 3 goes to the other side, becomes positive 3. And in the end, we get f inverse of x equals x plus or minus, we'll decide in a bit, x plus 7 upon 2. Now, since the domain of fx is decreasing, it's less than or equals to 3. So the range of fx, so the range of f inverse of x is going to decrease as well. So there will be a negative sign here because of that. Okay, if it were x is greater than equals to 3, then we would have chosen the positive sign. Okay. Now, the next part says that find the domain of F inverse. Now, the domain of F inverse equals range of F, domain of F inverse equal range of F. Now, what is the range of F? We can see that the range of F is greater than and equals to -7. So then the domain of F inverse is also going to be greater than and equals to -7. Okay. Then it says that gx equals x plus 3. Let's write that down here. Gx equals x plus 3 and the domain is x is less than equals to p. With k now taking the value of 1. So fx is 2 times x minus 3 whole square minus 7. And it says that it's going to be x is less than equals to k, but k is now 1. So with k now taking the value of 1, find the largest value of the constant p, which allows the composite function fg to be formed. Okay. And if and find an expression for fg when it exists. Okay, so now they're talking about when the composition fg is possible or not. We have studied that the domain of g, this is g, and g is 2x, x plus 3. The domain of g should lie within the range of f. F is 2 times x minus 3 whole square minus 7. Basically, for now, G is being fed to F, right? That is what FG is. We substitute G in F. Now, the output of G should lie within the input of F. Or in the class, we used to say that we start from here, range of G must lie between domain of F. Okay. Now, what is the domain of F? It is x is less than and equals to 1. We already know. And what is the range of gx? Range of gx is simply gx itself, right? That is how we write range. Domain is x and range is gx itself. So gx is x plus 3, or gx should lie within the domain of f. So it's going to be gx less than and equals to 1. Let me repeat what I'm trying to say. The range of gx must lie within the domain of fx. So the domain of fx is less than and equals to 1, and the range of gx is just gx itself. So we're going to write gx is x plus 3 less than and equals to 1. So this becomes x is less than and equals to -2. And in the question, it says x is less than and equals to p. So that means p is equals to -2. That's the value of p. So that the composition FG is possible. Okay, next they're asking for the expression FG. So we know for that we just substitute G in F. So 2 times, instead of X, I'm going to write X plus 3, then a -3 whole square minus 7. That's just 2x square minus 7. That should be the answer for last part.